This is part 2 of the 5.09 review. Predict the effect of adding heat to a reaction. Sulfur dioxide, SO2, a gas produced by volcanoes and in industrial processes, can combine with oxygen gas to make sulfur trioxide, SO3, a gas that can form acid rain when it mixes with water in the atmosphere. The reaction that forms sulfur trioxide is exothermic and reversible, as shown below. So the SO2 plus oxygen yields 2SO3 plus heat. If you add heat to the system, which way will the reaction shift? Okay, so think of putting a coefficient of a 2 in front of the heat. So we have extra heat. Recall relevant concepts. Le Chatelier's principle states that a system in equilibrium reacts to environmental changes in such a way as to maintain equilibrium. In this reaction, heat can be considered a product. According to Le Chatelier's principle, if the concentration of products increases, the system will shift toward the reactant side of the equation. Part 2 solved. Because heat is present as a byproduct on the right side of the equation, the reaction will shift to the left to favor the reactants. The concentration of SO2 and O2 in the system will increase, and the overall concentration of SO3 will decrease. Example 2. Predict the effect of removing heat from a reaction. Hydrogen gas can combine with chlorine gas to make hydrogen chloride gas. When you dissolve this gas in water, it makes hydrochloric acid, a chemical that helps dissolve food in your stomach and also has a wide range of industrial uses. The equation for the formation of HCl is shown below. So you have hydrogen plus chlorine yields HCl plus heat. If you cool the system, so cooling means take away heat, which way will the reaction shift? Recall relevant information. Again, heat can be considered a product of this reaction. According to Le Chatelier's principle, removing a product from a reaction at equilibrium will tend to shift the reaction towards the product side of the equation. So there's less of it, we need to make more, and so the reaction is going to go to the right. Cooling a system involves removing heat. Therefore, the reaction will shift towards the product, the right side of the equation. The concentrations of H2 and Cl2 in the system will decrease, and the concentration of HCl will increase. Example 3. Tip. Remember that the coefficients in a chemical reaction indicate the number of molecules of each species that are involved in the reaction. The coefficients also indicate the ratio of the number of moles of each species that are involved in the reaction. Therefore, to determine the number of moles of gas on each side of the reaction, add up the coefficients in front of all the gaseous species. Remember that a species with no written coefficient actually has a coefficient of 1. Predict the effect of increasing pressure on a reaction. Nitrogen gas, N2, can react with hydrogen gas, H2, to produce ammonia, NH3. This reaction is at the core of the Haber process, the main process for producing ammonia on an industrial scale. Fritz Haber, a German chemist for whom the process is named, took advantage of Le Chatelier's principle to maximize the production of ammonia. The Haber process equation is shown below. N2 gas plus 3H2 gas yields 2 NH3 gas. In the Haber process, nitrogen and hydrogen are allowed to react under very high pressure. Explain why high pressure would increase the amount of ammonia produced by this reaction. Recall relevant information. As pressure increases, gases become less stable in the system. Therefore, an increase in pressure will tend to favor the side of the chemical equation that contains fewer moles of gas. In this reaction, there's 4 moles of gas on the reactant side, so 1 mole of N2 plus 3 moles of H2 equals 4, and only 2 moles of gas on the product side. Because increasing pressure causes the reaction to proceed toward the side with fewer moles of gas, the high pressure of the Haber process will cause the equilibrium of the amount of ammonium reaction to shift toward the product side of the equation, that is, toward the ammonia. Predict the effect of decreasing pressure on a reaction. All right, so look at the chemical equation, hit pause, see if you can figure it out. Solid nickel, Ni, can combine with carbon monoxide gas, CO, to make nickel carbonyl, Ni, parentheses, CO4. This compound is extremely toxic. It is used in nickel plating and nickel ore refining. Here's the equation for making nickel carbonyl. Nickel as a solid plus 4 carbon monoxide molecules as a gas yields NiCO4. CO4 as a liquid. If you decrease the pressure in the system, which way will the reaction shift? How many moles are on the reactant side? 1 plus 4 is 5. How many moles are on the product side? 1. And now we're decreasing the pressure. Recall relevant information. As pressure decreases, gases become more stable in the system. Therefore, a decrease in pressure will tend to favor the side of the chemical equation that contains the greatest number of moles of gas. In this reaction, there are 4 moles of gas on the reactant side and 0 moles of gas on the product side. Oh no, sorry, I made a mistake. I forgot we have to look for gases and we only count gases. So even though there's 1 over on the right-hand side, it's liquid, and we don't count this one over here on the reactant side because it's solid, we only count the 4 for gases. Because the reactant side of the equation contains more moles of gas than the product side, a decrease in pressure will cause the equilibrium in this reaction to shift towards the reactants, or in other words, to the left. Example 5. Predict the effect of increasing concentration on a reaction. Hydrogen gas H2 can combine with iodine gas I2 to make hydrogen iodide, HI. This compound is a colorless and odorless gas that can be dissolved in water to make a strong acid. Here's the equation for making hydrogen iodide. H2 gas plus I2 gas yields 2HI gas. If HI is added to the system, which way will the reaction shift? Okay, so we have more over on this side. Hit pause, get your answer, recall relevant information. According to Le Chatelier's principle, if you increase the concentration of products in a system at equilibrium, the equilibrium will shift toward the reactant side of the equation. So adding HI to the system will shift the reactant to the left or to the reactants. The concentrations of H2 and I2 will increase and the concentration of HI will decrease. Tip. In the context of Le Chatelier's principle, concentration can mean either a typical solution concentration or the concentration of the reactant or product in the system. That is, the relative number of moles of the reactant or product in the system as a whole. So we could increase concentration and say 0.5 molar instead of 0.2 molar, or we can just say, oh, we doubled the amount of moles. So either way is basically legal. All right, what about if we decreased it? So if some Cl2 is removed from the system, so we take some of this away, which way will it shift? Removing Cl2 from the system will cause equilibrium to shift to the left. So we took some away, so it needs to go to the left to make more of it. The concentrations of cobalt and dichloride will increase. The concentration of CoCl2 will decrease. All right, you need to do problems 1, 2, and 3. Go ahead and do them. Hit the pause button and then hit play, and I'll talk through all 3 of them. Number 1, predict the effect of removing O2 from the following system. 2SO2 plus O2 yields 2SO3. And the answer? So we got rid of some of this, which means we need to make more to get it balanced. To make more, we're going to go to the left, and we're going to be making more reactants. Number 2, predict the effect of removing heat on the system shown below. So we took away heat, we have less heat. Answer is, we need to make more heat, so it will go to the right and make more of the products. Number 3, predict the effect of increasing pressure on this system. Answer is, so the first thing I'm going to do is I'm going to look that they're both gases. Yep, they're both gases. How many moles of each? I have 1 mole on the left, 2 moles on the right, and I'm increasing the pressure. I'm squeezing it together. So which way is it going to go? It wants to go towards the side with less moles, so it's going to go to the left, to the reactant side. So again, because it only has 1 mole of gas versus 2, it will go to the left toward the reactant side. Or if you want to read the official answer, increasing pressure favors the size of the equation with the fewest moles of gas. The reactant side of the equation contains 1 mole of gas, and the product side contains 2 moles. Therefore, increasing pressure will shift the equilibrium toward the reactants, or to the left. The concentration of N2O4 in the system will increase, and the concentration of NO2 will decrease, because we want more of these molecules. That's it. As always, if you have questions, let me know. Otherwise, go ahead, if you're ready, take the 2.09 quiz.